All right, y'all, so I'll get into 9.3 that deals with exponential functions. So it won't be too bad today. All right, so we start out introducing us to a constant that we have in math. Y'all ever seen that little E? They call that Euler's number. So we won't get into how that number came about, but it has to deal with compound interest type formulas, and it's a horizontal asymptote those graphs try to reach over time. So we're not going to worry about where it came from and all that. We're just going to play with it on the calculator to evaluate it. So it's a constant like pi. So, So on your calculator, you got the E in two places. The first place on your calculator to find the little E is if you hit the second and then the division. You should see a little blue E right above the division sign there. So if you hit the second button and then the division, it'll put the E on your screen. And if you want to see what its value is, we just hit enter on that. And it's roughly 2.71828. And I use curvy print equals mean we're approximating it because it's a never-ending decimal just like pi. So they just want to get us familiar with that because in section 9.4 and 9.5, we'll start dealing with what we call natural logs, and that's the base of those logs. So at the end, I'll sort of get y'all good on logarithms. So they wanted us to use a calculator to approximate. Oh, and my first one is, and this is going to go to 4 decimal places. So this first one is e to the third. So when I do the e with exponents, the button I'm going to use to find these is going to be second ln. So you got an ln on the left side of your calculator, right by the 4. So if you'll hit the blue button and then the ln button, it'll pull the e up, ready for the exponent to go in. And then I'll just punch in my 3 there and hit enter. So let's see, it'll be 20, and then we need what, 4 decimal places? Looks like 08, 5. Okay. And then they're going to do one with a negative exponent for us. Well, how about e to the negative 3.45? You know, we'll say this, when you see negative exponents, those answers should be less than 1 because negative exponents are sort of like fractions in disguise, okay? So let me push that in. I'm going to hit second ln again. And then negative 3.45 is my exponent. And so you should be getting a nice little decimal there. Looks like what, a 0.03 1.7? I guess I should be looking up there, right? I've got it right there. And then just remember, you're going 4 decimal places after that decimal there, okay?
I'm getting something.
What are you getting?
Error.
Was you using this negative or this negative? So what? Yeah, so it won't let you use the subtraction key for negative numbers. So always use that little negative ending in the parentheses down there, okay? All right, so that's all we're gonna play with that for a little bit. I think I just threw that in there just to get you familiar with it, okay? So we're gonna look at exponential graphs. And boy, oh boy, y'all been seeing exponential graphs every day on the news if you've been watching that COVID. The way them graphs double really quick. So that's exponential graphs. They double really quick at times, okay? All right, so first thing, all these graphs, they're going to cross the point zero, 1. Oh, let me put this up here. Exponential graphs will be in this form. F of x equals a to the x. So my variable is now going to be the exponent on these. And the reason they all cross this point, because any number to that 0 power equals what? Now you got that calculator asking? Oh, well, I just heard it. All those are going to equal 1. So no matter what number I'm putting in for that a, once I throw a 0 up for that exponent, it's going to equal 1 for me, okay? These graphs are continuous, which means they'll have no holes in them or no asymptotes happening. So they'll be defined for all their points. So they're continuous graphs. Also, on my basic graphs, I know if that a is greater than 1, then my graph is going to increase. Oops, that should say yes. If a is greater than 1, the graph is going to increase. If a is less than 1, and I'm talking about the absolute value of the a, and I'm not worrying about negative stuff at the moment. We're just looking at a. If a is like a fraction, basically, then these graphs are going to decrease. That's because when you take fractions and you square them, you square the top and the bottoms. Well, those bottoms are going to grow a lot quicker than that top. So it's almost going to just try to get to that 0 like on them asymptotes. Okay? What I'm going to do, I'm going to graph one with greater than 1 for the a, and then I'm going to graph me a fraction. Okay? And I'm going to find little numbers because exponents grow quick. So let's graph f of x equals 2 to the x. Okay? So I'm going to come up here and make me a little table. And then I'll even throw a negative number in there to show you what happens to these when you put negative numbers, okay, for those exponents. So, boy, I'm gonna really start with that 0, right? Because I know that y value is 1. And then just pick some exponents. I'll just try a couple. I might even go up to a 3, then you can see it really growing. So if you put a 1 in there, anything to the first power is basically itself. So that's just going to be a 2. If you put a 2 in for that exponent, 2 squared, will give me a 4. And then how about 2 to the third? 8. But what you noticing, this is doubling every time. Okay? And if you ever watched them talk about the COVID, they talk about the doubling. In the beginning, it was taking about a month to double. That was taking, what, about a week? We're going like 1 million a week now or something, y'all. So, exponential graphs. Now, I'm going to throw a couple negatives down there to refresh your own negative exponents. But if you had 2 to the negative 1, your first goal was to make the exponent positive by putting all that under a 1. So that this would become 1 over 2 to the first. So you move exponents up or down to change their signs. But now on the bottom, that 2 to the first is a 2. So that's basically just going to give me a 1/2. Now what's nice, that calculator will do these negative exponents. You can put a 2 in, and then hit that caret up and put in, what, a negative 1. Once I hit enter, I get 0.5, but remember, I can hit math and enter twice and turn that into a 1/2. Okay? So what's going to happen to that negative 2 here? So I got 2 to the negative 2. And basically what we're doing is we're just flipping the numbers because they all got 1s under them. So you're just flipping them. So this will be 1 over 2 squared. And notice you don't never change the sign of anything but that exponent when you're moving them up and down. So that's going to give me 1/4. So these negative exponents are matching the positive exponents, but they're all under 1s. So this means on this side, it's getting really, really, really close to that 0, okay? All right, so let's graph that. That's why I picked little numbers, so I keep my, if we put 3s here, that would have already been, what, a 27, 3 to the third. So you gotta watch the numbers. Now, I will say MATLAB, on these ones, you're just going to pick one of their 4 pictures, okay? Alrighty, so I had 0, 1. It's going to go right through the center. And actually, all these are going to go right through there until we start moving them around in a little bit. All right, then I have that 1, 2, 2, 4, 3 was up here at 8. So you can see this is not like a linear line. It's got some curvature to it. And over here at negative 1, I was at negative 1/2. At negative 2, I was at a 1/4. Then I'd get a 1/8, 1/16. It just keep on trying to get to the 0 so that this comes along and then shoots up. Okay. In MATLAB on these, when you're graphing them, they'll have this exact shape for your tools to pick out of, okay? So if you don't try to stop these graphs, they go uncontrollably after a while, okay? one person gets 2 people, then 2 people get 2 people each. That's what this one's saying, because we're doubling it every time. Well, if you started with 4 or 5 people sick at the beginning, well, just after 2 days, that'd be what, 25? Because you're squaring them and, whew. All right, so let's graph the fraction one. So I will do, I'm gonna keep it small with the 1/2 to the x. And guess what? I'll still use 0. So you know 1/2 to the 0 is 1. Because either 0 would apply to both numbers, and it'd be basically a 1 divided by 1. Okay? So I'm going to use a 1 there, and 1/2 to the first power is a 1/2. Put a 2 there. So 1/2 to the second, you would square the top and the bottom. So 1. So we can see what's happening in my positive direction. I'm definitely decreasing. So let's try a -1 in there. So we will have 1/2 to the -1. So our first goal, we want to make the exponent positive. So we're going to flip it and make that a +1. So this becomes a 2 over 1 to the first power, which is just the 2, right? So the negative exponents, they're flipping them fractions and then they're squaring them, okay?
I don't like this.
So if I was to put me a -2 there, 1/2 to the -2 would definitely be a 4. So it's going to flip it and make that into a positive number now. So we can see what's going to happen. If I put a 3, -3, that's going to be an 8. So they're going to grow to the negative side. Oh, we kept that pretty small. You know, like I said, these will all have pictures for you. All right, so we crossed at 0, 1 again. At 1, I was at a 1/2. At 2, I was about a 4. At -1, I was at 2. And at -2, I was at 4. So it's almost like you took this thing here and flipped it across the y-axis, sort of. You know, all these pictures are pretty easy to look at. They got one going uphill like this one. They'll have one going downhill like this one. And then they drew a parabola for one of them, like a U. And then one of them's a straight line. So if you get an idea of these, it'd be easy just to go through and pick them answers really quick. Okay. Now, we'll say if you graph this one in the calculator, put parentheses around that fraction. Okay? That way it knows the exponent's applying to the whole fraction, okay? All right, but y'all know we like to move graphs around, right? Up and down, left and right, flip them. And we've even got a new move on this one. So these are going to be our transformations. So we're still going to do a vertical transformation. When we get a vertical transformation, I'll have f of x equals a to the x plus or minus b. So I added numbers in the chapter, what was it, like 8.1? When I added a number to the end, it either moved me up or down. If the B was positive, it's going to move me up. And if that B was negative, it's going to move me down. So that one's basically the same as it was in 8-1, okay? Then I can do a horizontal. That's going to move me left or right. So to move horizontal in a exponential function, you'll have A to the X plus or minus C. And it's still similar to when we did the parabolas. I'm attacking that X. On the parabolas, we had the X's in parentheses being moved left or right. Well, since that's an exponent, it's like all this is in parentheses, basically. So, when I attack the X, if I add to it, I'm going to move to the left. So it still moves left when you attack the X. And if you subtract from that X, it's going to move me to the right. But that's the same way as it was before. When y'all had stuff like this, remember when they was in parentheses when we said, well, we add 2 to the X, it actually is moving left. Because it's changing the value that's being hit with that exponent, okay? I can still reflect across the x-axis. So to reflect across that x-axis, I'll have f of x equals negative a to the x. So my leading term becomes negative. That's going to flip that whole graph over, okay? So the new move, I can reflect it across the y-axis. So to reflect across the y, you're going to have f of x equals a to the negative x. Okay, so put a negative in front of the lead coefficient, it's going to flip it over to x. But if you put that negative in front of that exponent, it's going to flip it across the y-axis. Because you're evaluating it all these values that are negative instead of being positive when you put it in there, okay? Now, very important for y'all. I sent a video this morning showing you how to graph these in MATLAB. I did that Zoom and was showing my screen on it so you can see the problems. When you're doing it in MATLAB, you're going to choose the exponential graph that looks like the curve going uphill, and then click the graph. Once you click the graph, it's going to pull open them little slide controls for the horizontal and the vertical. Y'all remember that? And you'll move the little bars and it moves the graph for you. The big difference on this is down in the corner of that, it's going to say base. The base is the number being affected by that exponent. So if that one I did walk over, I had 2 to the x, my base would be at 2. So you got to go in there and click it because by default it's got that little e down there. Okay? So you have to change it to a 2 or a 3 or whatever they're going to hit you with. Okay? So I'll send a video showing y'all how to do that. Alright, so I'm mainly just going to tell what I'm doing to these instead of graphing every one of these. I can graph them on my calculator to sort of show you the graphs. So what we're going to do is describe how the graph can be obtained from the basic exponential function. So I'm going to have f of x equals 2 to the x minus 2. So all I'm worried about is what's that negative 2 doing to my graph? So in MATLAB, you got to tell what you're starting out with, your basic graph. So my basic graph is going to be f of x equals 2 to the x. And I'll tell you, I think in MATLAB, they put the x, so all you got to do is put that 2 in there, because it'll have a little x off to the side for you. So the basic graph was 2 to the x. So what is that subtracting that 2 doing to my graph? So that looks like this case. And I'm subtracting it, so it's going to move me to the, what else I move? Right? Oh. So it moves me right 2 units. So I'll show you on here when you graph that. I got 2, then I'll do my exponent. Now notice, if you got the old calculator like me that I'm using today, notice it don't kick it up like a box. So on this one, I would have to put the x minus 2 in parentheses on mine. Now, y'all should just kick it up there. If you got the newer calculator, it kicks the box up, and you'll just put x minus 2, and it should all show it above it. Okay? All right, so let's see. That graph we said moved left, so it was crossing at 1 on the, we moved right. And you can tell that this point was over here at 1, and looks like it's moved it right about 2 units on me, right? So did y'all get one similar to that?
Say what now? Hold on.
Oh, you're shaking. Go just get a. So you got some shading going on. Go over here and unshade those. What's happening here? So just hit in there. And that goes back to the. If you want that window fixed, get zoom 6. And then look this one. And actually, it's kind of bad. There's just all like that, right?
Mr. Rathon,
Uh-huh.
let me see what yours look like on the graph.
Okay, so can you see that?
Yeah, I didn't get that.
So go to your y equals. Can you see my y equals?
Okay. Okay, that's why I didn't get it. I see it now. So 2 parentheses x minus 2 parentheses, and then hit graph.
All right, how's it going now?
Okay, I got it.
Okay. All right, so the next one we're going to look at is f of x equals 4 to the x minus 7. So we're going to go in and tell our basic graph. And that's what? F of x equals 4 to the x. So I've just got one move I'm worried about, really, and that's this negative 7. down, there you go. It's gonna move me down, what, 7 units? Okay, so you just gotta see where they're putting numbers and which case is happening to us, and then put that in there. So graphing that one, you'd go to your y equals, and that'd be 4 to the x, and then minus 7.
Okay.
And I'm just gonna hit my graph. And notice it brought that down. So my
Yeah.
graph is way below the x-axis now than it was. Looks like about 7 more units down, maybe. Okay. All right, slope, you see that? How it brought it down 7?
Yeah, I see it.
Okay. So that's the thing you're gonna be doing with these. So let me do some tricky ones.
Uh-uh.
I'm just gonna do some of these so you'll see what you gotta do when you hit them in that math lab. But this one has f of x equals 3 to the 1 minus x plus 2. So I'll tell you what I'd probably do to that is I'd probably rearrange this up here. And I'd probably make this a 3 to the negative x plus 1. And then bring down my plus 2. Okay? So I got 3 moves on this one. So I'm going to start with my basic graph. Will be f of x equals 3 to the x. So all your basic graphs will be just that number and that x up there, okay? So I got this move happening, that plus 1 happening, and that plus 2 happening. So let's see, MATLAB, yeah, they go right in order. So, plus 1, what's that plus 1 doing to me? It is moving me left. Remember, opposite sign on these ones. So move left 1 unit. What tree you get them to? Y'all got what? 2, 4, 6 moves that could be, or combinations. What's that negative doing? That negative x is going to reflect across one of them 2 axes. You're saying the y? You're saying the y? You're saying the y-axis? Remember, if I hit the exponent, it flips me on the y-axis. So to flip it on the x, that negative would have to be in front of that 3, okay? Now, what's the plus 2 doing? Y'all are good at that one. What was that?
I'm not saying anything.
It's going to move it up. Okay, so up 2 units.
Yeah.
So that one be really picky if you got an older calculator like I'm using today. So I would go to y equals. I would put in my 3 first, then my exponent. So since I'm having to use parentheses on mine, that would be a negative x plus 1. Close my parentheses, and then I would do a plus 2. On y'all newer ones, when y'all put in that negative x plus 1, make sure you arrow it back down before you put in your plus 2. All right, then hitting graph. There you go. Hopefully y'all get something like that.
Yeah.
Mm-hmm. Because remember, this graph originally should be going uphill, but now we reflected it and it's going downhill for us, okay? Let me see, y'all getting that graph? Oh, you're good now. So let's get two. You don't like that, man? Mm-hmm. So we'll get it one of these days. All right, so f of x. So we'll do one more and then I'll break out a formula for you. So this one had 5 minus 3 to the negative x. I would probably really rearrange that one. So what this one's really saying is I got a negative 3 to the negative x plus that 5 is going to be at the end. They just threw the 5 in the front to throw y'all a curveball on that one, okay? So basic graph would be f of x equals 3 to the x. And I've got at least 3 moves on this one. You got a negative there, and then that number sitting at the end, okay?
Okay.
So, that negative right there is going to flip me across the
X-axis.
x-axis. There you go. Well, what about the negative in front of the x?
Move it down.
Well,
No, don't move it down. Hold on.
that one's going to reflect me across the other axis.
So
That negative x is going to reflect
the y-axis.
across the y-axis. So I've done flipped it twice, and now the plus 5 at the end. That's going to move me up 5. So what's weird in math lab, you got to pretty much do the reflections first and then move it up. If you move it up first, it freaks it out for some reason. So I've been noticing that on math lab. But remember, on all these, you got to come in and put these bases down in the corners of those graphs down there when it brings up that box. Okay. So to finish this off, we got a little exponential formula for y'all. And this is a compound interest. So y'all seen simple interest. Simple interest would be like the bank's charging a 5% interest a year. So once a year they go in, figure out what 5% is and add it to it. There's also a thing called compound interest. Compound interest can be compounded annually, like simple interest, semi-annually, which is twice a year. They hit it with interest and then hit it again. Quarterly, 4 times. Now, we don't get hit with this, but they could be daily. Okay?
Mr. Rathon,
Yes.
are you doing this in your math reasoning class too?
Oh, I did some of this, but not as deep as y'all are getting.
I'm talking about the compound interest.
Yeah, we did that in the beginning. Oh, that's right. You had that class.
Yeah, and I got my worksheets. I'm gonna bring it Thursday and show you what I worked on.
They're really similar formulas. We just got different symbols in here.
Okay.
We don't break out the APRs on the math reasoning, folks.
And the APYs.
All right, so let's see if you remember what this is. I got A equals P times parentheses 1 plus R divided by N, all raised to the N times T power. So that's close for y'all, but we just called it interest rates and stuff. We use big words in that class instead of the little symbols.
Mhm.
But y'all, A is the amount in that account. What do y'all think that P is? Principal balance, or your starting amount, okay? So your principal, your starting amount. So 3 things left. How about the R? It is definitely interest rates. But remember, when you put that R into my formula, it better be in decimal form. So y'all got to convert them percents by moving that decimal left twice, okay? What about the N? Something different on this one. How about the number of compounds per year? So that's the number of compounds per year. So that would either be 1, 2, 4 in this class usually. I haven't seen anything bigger. And then T is time in years, okay? So T's are time in years. So not a bad formula, but if you're doing order of operations, you got to work the middle first in these parentheses, then raise them to whatever product of exponent you got, and then the last step, multiply by your principal. So this finds all the interest that's added when you multiply that principal, okay? All right, so this problem has a few parts to it, okay? So we're going to suppose $57,000 is invested at 5.5% interest, compounded quarterly. So first off, for part A, I'm going to find the function for the amount to which the investment grows. Let's see, grows after T years. So they're not telling me what the years are yet. They just want me to come up with a formula that I would use, that if I knew the years, I could just plop them in and get me a quick answer. And then part B, we'll find values at certain years on this, okay? So I know it's going to be A. Now in MATLAB, they call this A of T, because T is the variable that controls this equation. Okay, it's going to depend on how many years I've had it, okay? P, I know P. That's my 57,000. So I'm gonna bring that down. Then it's 1 plus, or I know if y'all fix it, that's 5.5. So that would basically be what, 5.5% in decimal form. But I got to move that decimal left to get rid of these percents. So that's going to be a 0.055, okay? So I got 0.055 on top. Yen. Because they went with quarterly on that. But notice now, you got an N here, but you also got the N times the T up there. At this point, we got the correct formula, but MathLab says, hey, y'all can do all that inside the parentheses and come up with a single number in there. So everybody inside the parentheses should have a 1 point, whatever they get, okay? So that this is a 57,000. Let me see what I get when I do the 1 plus.
So y equals,
So that's 1 plus, what, 0.055 divided by 4. So I'm just sort of simplifying inside the parentheses. And I'm getting a 1.01375. All to the 4t. Put all the decimals in there, because y'all's, it's not going to be much more than 4 or 5 digits. Some of y'all's be a little quicker, okay? All right, so this is what MathLab wants for that answer. So if you put it in this way, I think it'll say you're correct, but not in the right form when it gives y'all the explanation. All right, part B. Part B says, find the amount of money in the account at t equals 0, 2, 5, and 10 years. And this one says round to the nearest dollar. So look at them answers. One wants you to go to the nearest dollar, and then the last problem I do is want me to go to the nearest cents. Okay? So if t equals 0, you would put a 0 right in there for that t, which gives you a big 0, right? But anything to the 0 power is 1. So that's basically 1 times 57,000, which will give me 57,000. Which makes sense. If no years have added, I'm going to stay where I'm at, right? Now, for 2, I'm just going to put a 2 in there and make that exponent of 8, basically. So I got 57,000 times 1.01375 raised to the 8, because that's a 4 times 2 now. So hitting enter, 63,580 to the nearest dollar. So y'all, I made almost $6,500 in 2 years just for letting my money sit in this bank account at 5.5% interest, compounded quarterly, right? But do you see what's happening? You're taking the 0.055 and dividing it by 4, so you're not hitting it with the whole 0.055 every time, but then you're bringing that 4 back up here to multiply by the years. So you're dividing it, but you're still carrying it out through them years. So it's still going to make good money. Better than simple interest. Simple interest is going to hit you once, you know, but you'll notice on compound, it'll grow a little quicker. Which might not be good if you're taking out car loans and stuff, right? You want simple interest on the car loans. All right, y'all, what was next? T equaled 5 years. Now, hopefully y'all are seeing your money grow on this problem. If you get anything less than 57,000, I would think it was some kind of operator error on that calculator. So at 5 years, I'm getting 74,000 something. Let's see what y'all are getting. I think I'm gonna round that to what, 902, I think. Well, that look good, 74, 902. And then finally, 10 years. Now, that's almost what, 17,000 you made in 5 years. I'd expect a little bit more for 10. So 57,000
What you putting in?
times, what was it, 1.01375. So that'd be an exponent of 40 now. Well, let's see, that looks like that's going to round that up from a 5 to what, a 6? So I'm getting 98. 426. Okay. So now you're starting to talk after 10 years, that's getting closer to doubling. Not quite, it looks like about what, 40,000 or so. I wish I had money I could just throw off on the side for 10 years and just let it grow, you know. But you are seeing how these exponential graphs grow pretty quick. So that's the main thing they're going to be able to see. So let's try this little lucky girl for this last problem. Little Melissa. So Melissa's lucky on her 6th birthday. So on her 6th birthday, Melissa got a $6,000 CD. So a $6,000 CD that earns 6% interest. Compounded semi-annually. So if it matures on her 16th birthday, how much money is available? I guess we're about to see if Melissa getting a car for her 16th birthday or what she's about to do, okay? All right, I didn't handle CDs when I got 16. All right, here we go. My principal balance is 6,000. Then we got 1 plus, what y'all putting in for R?
0.0.
So 0.06. N, 2 for semi-annually.
Hello?
2 times, well, what is the years?
16.6.
Which is 10 years, good job. So mature means you can get 100% what's in there. I think if you get it out any earlier, they're gonna hit you with penalties and early withdrawals and stuff, but if you let it mature, let's see what she gets. Now, this one wanted me to round it to the nearest cents. So let me write that here. What did it say? Round the nearest cents. Well, I'm getting like 10,000 something on her. I'm going 67 cents. All right, so that's 9.3. So I'm just going to give y'all something to get y'all ready for 9.4. Just explain what a logarithm is. Y'all ever seen logarithms? So this just to get you a little bit of knowledge for the next lesson. So a logarithm comes in this form. Okay, so watch this. This 2 is what we call the base. This A is the result. What this logarithm is going to find is the exponent that I would raise the 2 to turn it into an 8. So how many times did you multiply 2 times itself to get me an 8? 3. So the log of 2 to the 8 is 3. And I'll show y'all next class, there's buttons on the calculator that do these logs. So let's see what y'all put here. Log 5 of 25.
What's that first word up there at the top above number 8?
Oh, result.
Oh, okay.
RESULT, result. It's the result you would get from taking this 2 and raising it to that exponent of 3. So 2 to the 3rd equals 8.
Okay.
What the log's finding is the actual exponents that are making them numbers turn into those. So what exponent was turn a 5 into a 25? 2. And if you want to check them, you just take the base, raise it to the exponent, and it should equal that 25. Okay. Now, don't think bad when you know what. Just remember, logarithms are exponents. So later in life, they're going to follow exponent rules when we start playing with those, okay? And you'll have to remember stuff.
4.
So how do you turn a 16 into a 4?
4.
Oh, you're so close. It is a square root. So you take the square root of 16 to turn it into a 4, right? You remember how to write square roots as fractions? A square root would be a 1/2. If it was a cube root, that'd be a 1/3. So when the result is smaller than the base, you're looking at square roots, cube roots, or even more, okay? All right, so I didn't want to get too deep on that, just to give y'all an idea what a log was. Y'all might have seen them in your life, I'm pretty sure. But we'll start solving equations with those next week. So next class, we're going to do that kind of stuff. Go through them, try to evaluate them. I'll teach you about the natural log, which is the LN. And that's just a log with a E for the base. Also, if you see this one on the calculator, it ain't got a number by it. That automatically means that that base is a 10. And then you got an LN on there. The LN is really a log with that little E for the base. And we'll be playing with, we'll evaluate both of those next class, the logs and the natural logs, okay? All right, so I'm going to quit sharing the board. So any questions online?
No.
And y'all are good in here? All righty, so I'll send this out later for y'all if y'all want it. And then next class, we're gonna start playing with them logarithms, okay?
All right. Thank you.
All righty, I'll see y'all later. Oh, and actually, all y'all that came pretty did good on y'all's test.
And me?
Yeah, you did good. You came. Whatever. But some of y'all's classmates, I don't know where they at. No, I got scores on there like 28s.
Yeah.
And,
Wow.
oh, I had a few in the 30s and stuff. And then all y'all that come to class and actually participate here and there were all in the 80s and 90s and pretty good grades.
Yeah.
So I ain't figured that one out yet, but we will.